Hello everyone and welcome to the lecture on elastic load balancing. So what is elastic load balancing? Elastic load balancing efficiently allocates incoming application or network traffic across multiple targets such as EC2 instances, containers and IP addresses in one or more availability zones. It ensures traffic is only routed to healthy targets, enhancing the availability and fault tolerance of your applications. It responds to changes in incoming traffic, adjusting its resources to maintain performance and efficiency. Types of load balancer. So first we have application load balancer. Second we have network load balancers. Third we have gateway load balancers. And fourth we have classic load balancers. So before I will discuss about the feature comparison between all the four load balancers, I will quickly talk about the 7 layers of open systems interconnection model, OSI layers. So first we have the physical layer, which is of USB, Bluetooth, Ethernet cables, fiber optics. Then we have data link layer, which provides reliable data transfer between two nodes connected by a physical layer, and examples include Ethernet, point-to-point, PPP, point-to-point protocol, SDLC. And third we have network layer, which consists of internet protocol, IP, ICMP, IP addresses, routing, internet protocol, OSPF. Then fourth we have transport layer, which is TCP UDP, and which provides the reliable data transfer between end systems. So TCP UDP we know, most of us we know because we have worked with like TCP UDP, through which the packet falls, and IP is the IP addressing layer through which IPs are get recognized and traffic flows. And fifth we have session layer. Example includes NetBIOS, SOCKS, point-to-point tunneling protocol. And then we have presentation layer, SSL, TLS, MIME, XDR. And last we have seventh we have application layer, which consists of HTTP, FTP, file transfer protocol, SMTP for mailing and all, DNS, domain naming service. So we'll just focus on these application layer, transport layer and network layer for our product comparison. So feature comparison. So we have four types of load balancer: application, network, gateway and classic. So on which layer does it operate? So application load balancer operate only on layer 7, which is application layer. Then network load balancer for layer 4 for TCP UDP. And gateway works on layer 3 and layer 4, which is basically IP and TCP UDP. And classic load balancer works both on layer 4 and layer 7, which is application layer as well as transport layer, TCP UDP. So target types we have, so application load balancer can point to IP and EC2 instance or the Lambda. Network load balancer can point to IP instance and application load balancer as well. So this can point to application load balancer. Then we have gateway load balancer, which can just target types are IP and instance, and classic load balancer again IP and instance. Then protocols. So it works on these protocol: HTTP, HTTPS, gRPC, and this one is TCP, UDP and TLS, and gateway only works at IP layer. And classic works on all the TCP, SSL, HTTP and HTTPS. Then layer 7 features we have, because it's work on browser level, the web browser HTTP layer we can say. So it allows like redirects, fixed response, HTTP header based routing, HTTP2 and gRPC, and others so not applicable. Then cross zone load balancing, so it supports yes and yes. So I'll show you what does it mean. So security features, it supports security groups, SSL offloading and server name indication. And then this one have security groups not applicable, and this one also supports SSL offloading. And then health checks, so we have HTTP, HTTPS, gRPC based health checks. Then this one have TCP, HTTP and HTTPS based health checks. And network load balancer only have TCP, HTTP and HTTPS. And this one has TCP, SSL, TLS, HTTP and HTTPS. Then Kubernetes integration, so it supports direct to pod and multiple namespaces. This supports direct to pod but at Fargate level. Then not applicable. Then logging and monitoring. It supports CloudWatch metrics and logging, and same for all others. How load balancers manage traffic. First, elastic load balancing efficiently distributes incoming client traffic among registered targets like EC2 instances in various availability zones. It constantly checks the health of registered targets to route traffic only to those that are healthy, enhancing the reliability. Then third, it is configured with specific protocols and port numbers. Listeners, so they are called as listeners, and listeners facilitate connections from clients to the load balancer and from the load balancer to the targets. And it includes all the application load balancer types that we have seen: application, network load balancer, gateway, and classic load balancers, and each with unique target management features. Then availability zones and load balancer nodes. So when an availability zone is enabled, elastic load balancing automatically creates a corresponding load balancer node within it. Targets registered in an availability zone that is not enabled will not receive any traffic. Ensuring that each enabled zone has at least one registered target maximizes the load balancer's efficiency. And it is mandatory for application load balancers to have at least 2 enabled availability zones for continuous traffic routing. If one availability zone becomes unavailable or lacks healthy targets, the load balancer can reroute traffic to healthy targets in another zone. So next we will see the cross-zone load balancing feature. So when enabled, cross-zone load balancing feature, when this feature is enabled, it allows each load balancer node to distribute client request across registered targets in all enabled availability zones, enhancing efficiency and utilization. But when it is disabled, each node only sends traffic to registered targets within its own availability zone, potentially limiting the effectiveness of load distribution. So I'll show you this via diagram. So this is how it looks like. So when this is enabled, so for example, you have a load balancer enabled and you have 2 availability zone, and these availability zone have on the both load balancer has put a network interface. So what it does, it will so you have one instance here and 4 over here, right? So it will distribute the traffic equally, like 20%, 20%, 20%, 20%, 20%. It's not like this will get 50% and this 50% will be shared by 4 instances. So this will get overloaded and overutilized and overloaded. So it will impact performance, but this will be underutilized. So this particular availability zone or this instance will get will have to take all the load. But if you have it disabled, so this is how it looks like. So because it will be like 2 availability zones, so it will 50% here, 50% here, and then 50% is shared by whatever number of instances that you have configured. So 12.5%, and this will have 50%. So this will this is the so that's why we will enable this feature in most circumstances, unless we have a very powerful EC2 instance or some instance running in some AZ, and we are okay to send the 50% of the traffic or higher percentage of a traffic. But most cases the cross zone load balancing is enabled so that it gets equally distributed among all the instances. And that's all. Thanks for watching.